Amy, every year, our wildfires just seem to get worse.
Well, that was certainly the case this summer, another punishing round of record-breaking wildfires.
This time, wildfires burned the largest amount of land in California's recorded history and a new largest fire ever.
So for those of you who may not live in California, here's what happened. Lightning strikes touched off hundreds of fires, at least hundreds of fires, and it devoured more than 1 million acres of land in 1 week alone. It overwhelmed firefighting forces, particularly with COVID limitations on crew size.
With incredibly hot and dry conditions, those fires joined with each other, creating these tremendous fire complexes, spewing smoke and ash across the entire state.
Several dangerous fires burning across Southern California in stifling hot and dry conditions.
Smoke to where you can't see in front of you, fire right on the road. The inside of your vehicle would heat up 30 to 50 degrees.
The whole thing was engulfed. It was just a ball of flames.
Smoke-filled skies in Los Angeles, clouds in San Francisco cast a red glow on the city.
We're not even really at the peak of wildfire season in California.
9 of the top 10 biggest fires in state history have happened in the last decade.
They've destroyed whole communities. It doesn't seem quite adequate to call them forest fires anymore.
All of this makes you wonder if we're underestimating the magnitude and speed of these disastrous, devastating events, which have climate change's stamp all over it.
So why do we say it's climate change? Well, record-breaking temperatures, for one. California summers are now 2.5 degrees warmer than they were in the 1970s. Kat, this year, LA County hit 121 degrees. That's the highest ever. And Death Valley hit 130. Did you read that? It's the highest temperature reliably recorded on Earth.
Those warming temperatures dried out vegetation, and studies have shown the number of extreme wildfire days has more than doubled since the early 1980s. And a UC Davis study just found that in our northern coastal ranges between Lake Berryessa and the Klamath Mountains, severe burns have increased 10% per decade since the 80s.
That's sounding more and more like climate change. You know, California this summer essentially had a black summer.
Quite literally, if you consider the smoke.
But do you remember that, though? The black summer is what Australians called their last summer of wildfires. By the time it was over, 33 people died, 3,000 homes were lost, and more than 46 million acres burned. That's an area nearly half the size of California.
Black summer might seem like a blip in our collective memory now, given what's happened this summer, or this year, but it shouldn't be.
I think it's very likely that we will have an event like that in California.
That's Malcolm North, a UC Davis forest ecologist.
There's just no way around the fact that sometimes everything lines up. And at least in Australia, it appears to have been some of the hottest, driest conditions they've had in the last 50 to 100 years.
We've seen our share of wildfire disasters here in California, too. Not just this year, but the 2017 Northern California wildfires burned down entire neighborhoods of Santa Rosa, killing dozens of people.
Then in 2018, it got worse. High winds, unseasonably dry conditions, and one spark from a power line was all it took to lead to the deadliest fire in the state's history, the Camp Fire, which killed 85 people.
And Malcolm says climate change will bring more destructive wildfires to California.
We're going to have not just places like Paradise burn up, but unfortunately we're probably going to see other places get incinerated as well on a much broader scale.
Landscapes will change, we'll lose some forests, and the loss of life and property Australia had will pale in comparison to the casualties we might experience.
We have certainly, if anything, even more of a propensity for it. Australia, I think in the entire country only has 20 or 30 million people, as we have 40 million in an area that's like 1/10 or 1/8 of the size of Australia. It's a matter of time.
Climate models all agree that temperatures are going to increase.
It's going to be hotter, it's going to be drier, fire's going to burn more frequently.
Maybe this is never going to be the way it was again.
We need to come up with ways to literally pull CO2 out of the atmosphere.
How are we going to work together to solve a challenge like climate change?
Coming to you from our closet studios as we shelter in place across the Sacramento region, this is Unfold, a UC Davis podcast that breaks down complicated problems and discusses solutions. This week, we unfold wildfires in a changing climate. I'm Amy Quinton.
And I'm Kat Curlin.
Kat, the first thing Malcolm said was that California doesn't just have one wildfire problem. We have several different kinds of wildfire problems.
Yeah, how they burn, how destructive or severe they are, often depends on their environment or habitat.
So probably everybody in Northern California is familiar with our big forest fires. Our conifer forests, which historically relied on frequent fire, have become dense with trees. It's a result of decades of just putting out every fire. And all those trees and brush are ready to burn when wildfires strike. And it's a scary thought considering we have 33 million acres of forest in this state.
There are other types of wildfires too, and some of the most destructive fires, where there's little you can do to stop it, take place in chaparral and oak woodland ecosystems.
And chaparral is a type of shrubland where you'll find really drought-tolerant plants with like hard evergreen leaves, and oak woodlands are lower elevation areas dominated by oak trees.
Fires in chaparral are often really hard to fight, especially if they're driven by Santa Ana winds.
But now, Malcolm says we're seeing these monstrous wind-driven fires happen further north.
LA and the Southern California has been dealing with it for a few decades, but the fact that it's moved up into central and even kind of northern California, that's something which is very recent and very disturbing.
Malcolm says the problem isn't so much the winds, but conditions on the ground when the winds hit.
Most people would say, and I would agree, shifts in the climate are making these extreme wind events occur when normally you would have had wet fuels that can't catch because you've had rainfall. But if you notice, a lot of these big fires are happening in October, November, even December with a campfire. That would not have happened very much in the past because everything would have been well soaked by rain at that point.
It's easy to get depressed by all of this, but there are solutions.
Yeah, Malcolm suggested alcohol.
No, really.
Okay, well, before we get to those solutions, let's look at ways UC Davis researchers are first trying to understand what's happening to our landscapes, and second, how to manage it going forward. Derek Young, a forest ecologist at UC Davis, is taking me deep into the woods.
We're within the footprint of the American River fire, which burned in 2008 on the American River district of the Tahoe National Forest.
That fire burned hot, flames engulfing the tops of the pine trees, what's called a crown or canopy fire.
We're in a severely burned patch where almost all of the trees that were here before the fire have died, and it's mostly a shrub field now.
The area is choked with shrubs. We can barely push through it. It's full of red-barked manzanita and this god-awful plant called whitethorn ceanothus. I'm sure butterflies love it, but I am not a fan of its long thorns. And I can accurately say I bled for this story. Derek says after a severe fire like this one, it can be impossible for conifer trees to naturally regrow. So forest managers typically replant trees.
Very few seeds survive in the soil from one year to the next, and especially after a fire. So they rely on seeds to disperse from surviving trees nearby. And when you don't have any nearby, you don't get very much regeneration naturally.
And while it's common to have some patches of forest burn severely with any fire, Derek says areas of forest that are severely burned are growing in both size and number. But to really get an understanding of how our forests are changing as a result of fire, he needs to get a bird's eye view.
Okay, so powering on the drone.
Derek is launching a Phantom 4 about 300 feet in the air.
Okay, it's ready. Here we go.
The drone will fly over almost 200 acres, capturing three-dimensional photos every 2 seconds.
We'll use the drone data to capture the structure of forest stands after a wildfire and the density and spatial arrangement of the surviving trees, because then we'll be able to use that to help us predict and understand the patterns of natural forest recovery after a fire.
Understanding those patterns can also help determine how best to replant trees. Without the drone, ecologist and Professor Andrew Latimer says getting this amount of data might take 10 years to map. He says with climate change, we don't have that kind of time if we want forests to remain forests.
As the landscape gets more arid, those landscapes will shift from tree-dominated to shrub-dominated or grass-dominated. And so what we're seeing these fires do is essentially press fast forward on the process.
Scientists call these habitat shifts type conversion, and it's already happening in California.
That's a really hard thing. I mean, it's especially hard if it's your own backyard and you fear or you realize that maybe this is never going to be the way it was again. And I think a lot of people are starting to face that in some areas, especially areas that are kind of like at a transition zone at the edge of the forest. And that's something that, we're wrestling with as scientists and land managers are wrestling with as well, because it's really hard to give up on a site that you've thought should be forest, even if the projections for climate change suggest you shouldn't have trees. It really won't support trees there anymore.
So, Kat, I think that Andrew described the worst situation of what could happen to some of our forests, that we'll lose them. But we can make our forests more resilient to climate change and to wildfire. Andrew and Derek are looking at the best ways to plant trees, as well as what species to plant in order to restore a forest after a wildfire.
What scientists have learned is that decades of planting trees in the same way, like rows of corn, doesn't work.
Yeah, foresters call it pines and lines because pine trees are evenly spaced in straight lines. Here's what Malcolm said about that.
What we understand now about the fact that you need to have groups of trees, you need to have openings, you need to have scattered individual trees, but if you put them all in a regular pattern like that, they are really susceptible to getting burned up when the next fire comes through. And when pines are that close together and the crowns are down near low to the ground, they don't just burn, they get vaporized.
And Kat, I remember that this happened in the Rim Fire in 2013. There was an area of forest in the Stanislaus National Forest that had been replanted this way after a fire in 1987. So when the Rim Fire hit, all of those replanted trees were just incinerated.
That's why forests need to have a more natural spacing, like what Malcolm described. Historically, fires from lightning strikes would sculpt forests, removing small trees and brush that could act as fuel.
And prescribed fires, which are sometimes called control burns, are a solution to helping our forests under a changing climate.
Air quality regulations in California often conflict with prescribed fire, even though one major wildfire can create far worse air quality than periodic prescribed fire. So what can we do?
Well, first, understand that not all fire and resulting smoke is bad, and it's far better than what happens if we don't return fire to these landscapes. The idea that these forests need fire, small restorative fires, is something that California's indigenous people understood well. And Kat, I know you had a chance to learn about this not too long ago.
Yeah, so I went out this spring on 2 cultural burns with some of our students, faculty, and some tribal members from across the region. And yeah, indigenous people have been doing cultural burns for centuries, and there's been a bit of a resurgence lately. Basically, cultural burns are the idea that fire not only destroys, but it can restore. It's not just this threat to be tamed, but a natural resource that we can harness. So I'll actually be talking a lot more about that in this feature story on our Climate and Science website, which you can check out at climatechange.ucdavis.edu.
Well, it's clear we need to change our attitude about fire and even change the way we think a forest should look. I mean, a lot of people think of forests as dense woods with lots of shade, something you can get lost in.
But that's not the way our Sierra forest should look. Right now, we have on average more than 300 trees per acre. Malcolm says historically there would have been more like 64 trees per acre.
That's a huge difference. And Malcolm suggested with climate change, we should envision forests with even fewer trees and instead protect those that can withstand drought and fire and store more carbon.
trying to even get people to consider what the historical levels used to look like as a target is a real stretch, because it's so different than what we presently have. To then even go beyond that and say, well, maybe we should even go a little bit lower density and have the forest a little bit more open, that is even pushing the envelope further. So it's going to be a heavy lift to try to get the public to kind of understand or even be agreeable to this idea that forest conditions don't need to change just a little bit. They need to change a lot to be able to absorb these stresses that are coming at them in the future.
Another reason to keep our forests less dense and more resilient is that when forests change to shrub, they can be far more flammable.
But even if reducing tree density is a heavy lift, Malcolm says there is reason to be hopeful.
Because there's alcohol.
No, better. Because there's money. California has targeted more than $200 million a year for the next 5 years to restore forest health. The money comes from revenues raised by the state's cap-and-trade program to reduce greenhouse gases.
And hopefully that money will stick. But, we've also seen changes in our national forest plans here in California. The plans require forest managers to let lightning strike fires burn, as long as they aren't threatening communities. The plans set aside half the acreage in 3 forests for this let burn policy, and that could go a long way to help forests under a changing climate. So we mentioned in the beginning of this episode that we have another type of wildfire pattern here in California, and those occur in chaparral ecosystems. And first, we should explain that chaparral systems are unique. I learned this from Emma Underwood, a research scientist in UC Davis Environmental Science and Policy Department.
They're only found in 5 places around the world, and they cover about 2% of the Earth's surface and have about 16% of the plant species. So they're really high in biodiversity. And as we can see in areas like Southern California, there's huge pressures on them from population increase and urban expansion. So they're really high in biodiversity, but also highly threatened.
That biodiversity is at its highest after a fire, because fire helps seeds bust open to bloom.
But here's the thing. While fire increases that biodiversity, chaparral evolved to have fire very rarely. And with urban expansion and population increases, we're seeing fires happen more often. Hugh Safford is an ecologist with the Forest Service and at UC Davis.
So today what's happened is now you have ignitions all the time from people. And so the major threat to chaparral is too much fire, very simply. For most Southern California chaparral, the mean period of time between fires in the data record that we have is, it's 50 to 60 years.
Now we have fires happening all the time. Hugh says chaparral is highly flammable.
And even though historically they probably didn't burn all that often, because of the way the fuel is arranged, it's highly continuous and very dense, and the canopy of those shrubs is connected to the ground. So when you can entrain a fire in chaparral, it immediately becomes a canopy fire, which is something you have a lot of trouble putting out, right? Big flames, lots of energy released, very dangerous. You should not build homes in those landscapes. Of course, we've done a lot, millions of homes.
Hugh says research has shown when you burn chaparral more often than every 15 years, you make it impossible for chaparral and shrubs to grow on that site.
And what grows instead are invasive grasses and weeds.
But it tends to revert to weeds. And we're so overrun with, Eurasian, Mediterranean, Central Asian weeds that are really well adapted to reproducing quickly, taking advantage of these sites.
Kat, I've seen this for myself. I moved here in 2012, and down off the 405 in LA, there is this area near the Getty Museum that has burned at least 3 times since I've been here. And that area is now full of exotic grasses and weeds.
So we're seeing type conversion there too. And those grasses and weeds can burn much more easily.
Right, so you take this highly flammable system and add millions of people in homes, add Santa Ana winds, and you can see why a bad wildfire is just waiting to happen.
So what happens under a changing climate in these systems? Emma Underwood says it's a bit of an unknown, which is what she's researching.
The climate models all agree that temperatures are going to increase, but when you look at the data on precipitation, it's all over the board. So if you look at 5 models of climate change, for example, some increase precipitation by 30%, the warmer, wetter climate change models, and some decrease it by 30%.
She says in chaparral systems, precipitation can make a huge difference in wildfire activity.
So a wetter environment would cause more growth of plants on the landscape, particularly when you have a lot of rainfall after a drought period. You can see more of a flush of vegetation, particularly in the herbaceous cover, which can be very flammable.
We've seen this happen in Southern California before, where a wet spring followed by a really dry summer and fall can make wildfires worse. So what's the solution?
Well, we don't have the same set of tools in chaparral systems as we do in forests. Research has shown that you can't thin chaparral. It doesn't stop fire. The fire gets into those tall shrubs, like Hugh said, and it immediately becomes an explosive, unstoppable crown fire. It's known to just leap from one shrub to the next. And the problem in those systems is that there are just too many sources of ignition, human ignitions.
Instead, we're going to have to make difficult decisions about where to put homes and have the political will to make changes. That includes zoning changes, but it also might mean fireproofing homes. I mean, take a look at what happened in Paradise.
Yeah, this is something that Malcolm mentioned. These extreme wind-driven fires are blowing embers from miles away, and it's the homes that are catching on fire. The forest and trees are surviving. The way Malcolm put it, we're all in the same boat.
You're all in one lifeboat, and you're only as strong as the weakest link in that lifeboat. So if 19 out of 20 people have done the right thing with their homes, they've built more protective eaves and they've closed off their attics, that's fine. But if one home gets ignited, then the source that burns all the other homes is homes, because the homes are actually really strong sources of heat that then start moving the fire, not from embers, but they actually move the fire from the heat and the convective heat of the house burning on fire to ignite all the neighbors.
If we protect one home and another home isn't protected, the fire can spread to the entire neighborhood. It's like bad social distancing.
Exactly. So let's sum up what we've learned here about how wildfires under a changing climate could reshape California's landscapes. First, forests in some cases are turning to shrubs, which can be more flammable, especially when a wind-driven fire hits.
So if we want forests to remain forests, we'll need to increase prescribed burning and thinning of small trees and branches.
And we'll need to learn more about how to replant trees to encourage their growth and make forests less susceptible to wildfires. Chaparral systems, like those in Southern California, are suffering from too much fire. The more it has, the worse it gets. Those fires can be unstoppable.
But people play a big role in those ecosystems. We can re-examine where we build homes and how we build them.
And remember, our home is only as fire resistant as our neighbors.
You can learn more about our wildfire research on our Science and Climate website at climatechange.ucdavis.edu.
And you can listen to more episodes of Unfold at ucdavis.edu/unfold. I'm Amy Quinton.
And I'm Kat Curlin. Thanks for listening.
Unfold is a production of UC Davis. It's produced by Cody Drabble. Original music for Unfold comes from UC Davis alumnus Damian Verrett and Curtis Jerome Haynes.